Okay, gentlemen, so the last time we were taking notes, we had just finished runway markings. Runway markings and taxiway markings are so thrilling. And then we started on taxiway markings. And we watched a video yesterday which had runway and taxiway markings. So what you need from me is this. So I'm going to go over this really fast since we saw the video last time. I don't have to show you any pictures this time. So taxiway markings have yellow lines. Unlike a runway that has a dotted white line in the middle of it, taxiway lines are yellow, and the center line, to tell you where to put the nose wheel, it's a solid yellow line. Does anybody remember from yesterday? I know this is going to be tough. What a non-movement area hold line looks like. Well, what does the line look like? Solid yellow and then a dot of the yellow. Yeah. So if this was, if you had lines like this. This would tell you you were where, if you were coming up like this. This is a trick question. This is not a non-movement hold line. This is going from the taxiway to the runway. Very good. Oh, there you go. So if I was in an aircraft, an airplane, or a helicopter sitting, let's say I'm in my helicopter and I got my tail rotor blade and I got my blades all spin around right here, and none of my aircraft can cross that first line. What do I have to do to be able to cross that line? I have to get confirmation from the tower or from ground control. That's right. So this is actually a runway hold line. So I did that on purpose to confuse you because it's really fun to confuse students. Now, I'm in my helicopter, I'm hovering. Anybody except Rodrigo. I come up to this line. What does it mean if I'm taxiing up towards that line right there? Pardon me? No, we're not coming up on a runway. Go ahead, Jonathan. You're coming up on probably a taxiway, but you're certainly coming up on an area that this area out here is in control by air traffic control, probably the ground controller. So back in here, this is when you're in the non-movement area. And non-movement doesn't mean you don't move, it just means air traffic control is in charge of you. So this has the parking ramps, like when we went out to the airport, we had all those airplanes parked next to each other. We were out here on the ramp, and the airplanes were parked. And if we had kept going down that row of airplanes, at some point, we'd have come across one of those lines. So that means if you're on the inside of it, on the inside of the solid line, you can taxi around, you can drive cars. I mean, you could probably have a motorcycle and pop wheelies and stuff. Okay, so that's the difference between a hold line for a movement area and a hold line for a runway. So we've covered the non-movement area, ILS hold line, we saw that one, the runway hold short line, mandatory instruction signs. What color are mandatory instruction signs? They're red with what kind of letters? White. So I'm sure you're writing that down. Yeah, I like the red. You know, generally speaking, you better stop and make sure that you have permission to use. It's almost always, these mandatory instructions, it's almost always you need permission to cross that line, either from the ground controller or the tower controller. And most of the time, for pilots, the mandatory instruction lines, it's you're hitting the runway, either the end of the runway or you're going to cross and taxi a runway. The location signs, the Kings did a good job yesterday. Mr. John King, he didn't lean into the camera and make his eyes get big like I was really hoping for. So I'll see if I can get one of those clips and bring it in, because it makes his eyes look really big, like he's got that disease where your eyes stick out of your head more than average. In any case, he said, black square, you're there. So that's the location signs are black squares. And if you see that sign, you're on that thing. If it says C, Charlie, you're on a taxiway. All the taxiways are alphabets, and all the runways are numbers. So most of the time you're going to see location signs as to what taxiway you're on. So location signs are black, and they tell you where you are, and they're squares. Direction and destination signs, those are what color? Yeah, yellow with black letters, black lines, and they effectively tell you if you turn left or turn right, this is where you're going to go, or to what taxiway or what runway, or it could be a destination sign to, like at Fresno, maybe it says ANG, Air National Guard, I don't know. All right, so I was looking at hand signals, and we're going to watch a short 5-minute clip on hand signals, and then I'm going to tell you the ones that you have to know for the test. You can get the lights if you want, Jonathan.
This video training program will address effective communication procedures that ground and flight operations personnel must be proficient with when communicating on the ground. Once the aircraft is in sight, the line tech will give the ready-to-guide signal. For this signal, stand with feet slightly apart and arms raised straight above the head. Like all forms of communication, the message you're trying to convey may be misinterpreted if you do not use the proper words, or in this case, the proper signals. It is important for the line technician to remember that his actions are being interpreted by someone at the controls of a very complex piece of equipment. To taxi the aircraft straight ahead, hold both arms out to the sides at a 90-degree angle and exercise both the forearms in a come-ahead motion. To signal a right turn, hold the left arm and wand outstretched to the side, while the right arm executes the come-ahead signal. To signal a left turn, hold the right arm and wand outstretched to the side, while the left arm executes the come-ahead signal. All marshalling signals should be performed at a slow, precise cadence. To slow the aircraft, hold both elbows at your side with the forearms forward and at a 90-degree angle to the body. Using the standard cadence, repeatedly move both forearms in a downward motion. Affirmative, thumbs up, is a signal used in many situations. It is used to indicate the acknowledgement of instructions, or that the area is clear to continue movement, or everything is okay. Negative, thumbs down, is the signal used to indicate no or not ready. To indicate clearance between aircraft and a fixed object, hold both arms overhead, approximating the relative distance between the aircraft and the object. To bring the aircraft to a stop, the signal begins with arms down at the side. Then, in a slow movement, raise both arms in a sweeping motion until the wands meet overhead and are crossed. This signal should be given when the aircraft is approximately 10 feet from its final parking spot. The line tech must not be abrupt with this signal, as the pilot will react immediately to the stop signal. Hold this position until the chocks are inserted. To signal an immediate stop, cross both wrists or wands above your head. To signal wheel chocks installed, raise both arms overhead with wands pointed inward toward each other. Make an inward motion with both arms, indicating the chocks have been installed. To signal set brakes, extend both arms overhead and clench both fists. This tells the pilot to set his brakes. To signal release brakes, hold both fists overhead, then extend and spread the fingers. This tells the pilot to release the brakes. To stop the aircraft engines, move the right hand and wand across the throat. Standard ground signals and procedures. Departure signals. To properly communicate with the pilot of an aircraft ready to depart, it is essential that you maintain direct visual contact with the pilot. To signal start an engine, hold the left arm out to the side with forearm pointing toward the sky. Indicate which engine is clear to start by indicating the engine number with the fingers of the left hand. To signal fire in the engine, extend and wave the right arm in a fanning motion below the waist. If it is a multi-engined aircraft, hold the left arm up and out to the side, indicating which engine has developed the fire. To pass control off to another guide person, stand facing the aircraft with the upper torso turned toward the next guide person, while extending both arms and wands in the direction of the guide person. To signal end of ground guidance, the line tech faces the pilot, gives a crisp military salute with the right hand, indicating that all is clear to depart. Once this signal is received by the pilot, the line tech will stand easy and monitor the aircraft's progress off the ramp while performing a last visual inspection of the aircraft. Let's take a look at a typical departure on a multi-engine aircraft.
Let's go.
Start engines.
All right, so I'm going to draw you a picture of what I want you to be able to recognize or draw on the test, if I can get to it. Okay, so stop. If you don't have wands, you're actually going to put your arms over your head and you're going to cross. So that's, yeah, if you don't have the little lights. And in the middle of the daytime, you may not, the ground person may not have them. So stop with, if they're raising their wands or they raise their arms up and they go like this, if they cross their arms, that means you need to stop. In theory, they're going to raise their arms up slowly. As you see them raising their arms, you're going to start applying brakes. And in theory, you'll stop right when they get their arms crossed. But you also got to understand that ground personnel are not always trained as well as they like. So they might see you coming, and they might just go up like this, and that doesn't really mean you better stop, or you're going to hit them. Just go ahead and stop. But usually by the time you're getting that close to somebody in the airplane, you're driving, you're only doing 1 or 2 miles an hour anyway. So crossed arms, that means you need to stop. The other one I'd like you to know is that if you run your hand back and forth across your neck, or the line person does, that means cut the engines. Or you could say turn the engines off. So that looks like this. And you always smile like you're about to die. No, I'm just kidding. I'm just kidding. They run their hand across their neck. That means go ahead and shut the engines off. Of course, you also got to understand, if you're the only time you're going to have somebody like this is if you're flying into a big airport under 2 circumstances. Hey, Mr. LaFaro, come on in. I'm doing great, thanks. The only time you're going to have someone on the ground giving hand directions like this is either you're flying into a big, like Fresno. There's a couple of FBOs, fixed base operators, that usually handle business jets. And when the business jet comes in, the ground people want to have that jet park in a certain particular spot, so they'll go out there and hold their hands up, and so the jet pilot will be looking at them, and they'll try to taxi around and face that person. So as soon as they can see that, say, Jonathan, would you do me a favor and stand up? Okay, so pretend you're a business jet. Johnny Business Jet. Can I call you Johnny Business Jet? Okay, great. All right. So if I put my hands up like this and you're the pilot of that jet, you're going to try to maneuver and come around and face it. So here I would be telling you to turn right. Okay. Then I would be telling you to go straight ahead. Go ahead, straight ahead. And as you're getting closer, I would up, and when they want you to park. And then they might do the, they go, thanks, Johnny, that's all I needed. So if they go like this, that means they're putting the wheel chocks in. I've never seen anybody tell them to set the brakes. If the wheel brakes or the wheel chocks are set, the pilot's going to decide to set the brakes or not. And I've never seen them say cut the engines, because that's what the pilots are going to shut down the thing as soon as possible. The only other thing that you're likely to notice here is turn left or turn right. And so in this case, you point the arm in the direction and you move the other arm back and right, and so that's a turn. So that one you're likely to see one way or the other. And then the other one you're going to see is if one arm is spinning around, that's the start engine. And of course, if they're not wearing dark blue pants and light blue shirts, you don't have to pay any attention to them. So those four right there are by far that's 95% of the time. If somebody's giving you signals like this, it's going to be one of those four. They're going to tell you to stop. They're going to be saying turn left or turn right. They're going to say shut off the engines, or they're going to give you the all clear to start up the engine. Granted, if you're a single engine airplane, do they need to point at which engine and then tell you to start it? Yeah, so they're probably just going to put their finger up and spin it around. And I know that's, unless you're at the airport in New Orleans in this part. Has anybody ever been in New Orleans? They just had Halloween there. My daughter lives in New Orleans, and two of my nieces went to visit her, and boy, they were spinning their arms around like this a lot in the last couple of days. Oh, the other place, besides going to a large airport where they have an FBO where they cater to business jets, the second most likely place where you're going to have this, and actually more likely is in a little airplane, is if you're flying into an air show or some kind of aviation event, and there's a lot of airplanes they have to make sure that all the airplanes get in the right spot, and they all park right next to each other. They'll have ground personnel waving you on quite a bit. Does anybody know where the biggest air show in the world is? Where is it? Not the name of it. I'll give you a hint. Wisconsin. How many people have been to Wisconsin? Yeah, me neither. All right, it's called Oshkosh. Now they call it AirVenture, but they used to call it. They used to just call it Oshkosh because it's at the Oshkosh. You know those jumpers on little kids, Oshkosh B'gosh? Okay, never mind. In any case, the Experimental Aircraft Association, the EAA, the ones that do the young eagles that to you, that organization, they have a week-long air show. And I say week-long, they have an air show that lasts for 7 days. And literally, for 4 or 5 hours each day, there is an airplane up there, or a helicopter, or a balloon, or something. And it's the biggest fly-in in the world. They get an air in the weekend, just before it's starting. They usually have one airplane landing about every 15 to 30 seconds. Yeah, on the runway and on the taxiway, and they're saying, "Follow, you're number 5. Follow those 4 airplanes," and they all just land. It's crazy. I won't get into it, but if you go to YouTube and watch videos about Oshkosh, Wisconsin, or the biggest air show in the world, that's where it is. That's like the mecca of little airplanes pilots. So that's on my bucket list is someday to go to Mecca, although you can't actually go in. Next topic is airport lighting. Who gets to turn on the lights? If it's at a tower-controlled airport and the tower is open, the air traffic controllers are going to turn it on, and they're not going to ask you. If it's a little too bright, you can ask them to dim it. If it's not bright enough, you can ask them to make it brighter. Most airports have towers. There's usually 2 or 3 intensities: low intensity, medium intensity, and high intensity. If there's a lot of bad weather, clouds and stuff, you're going to want the lights on as high as you can get it. But the air traffic controllers have a lot of practice, so they usually set it to what most pilots are going to want. If you fly to an airport that does not have a control tower, like Reedley International Airport, then, the lighting is controlled by the pilot. And generally speaking, at any pilot-controlled lighting, if you turn it to your radio to the CTAF frequency, the Common Traffic Advisory frequency we've already talked about, and you click 7 times within 5 seconds. And the lights will come on to their highest level, and they'll stay on for 15 minutes. So let's say you're coming into Reedley, and it's at night, and you're 10 or 15 miles away. You've listened to the audio system, and you're listening to the frequency for the airport, and you don't hear anything, and you're going, where is it? Now, I know where it is because there's a winery about a mile away from the airport, black spot where Campbell Mountain is. So I'm used to flying into that airport. I can fly in there at night with one eye shut. It's probably not a good idea if I shut my eye. I shut my bad eye, so it wouldn't be so bad. But if I'm on that frequency and I'm 15 miles out, I click, 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 click 7 times, and the lights will all come on. Yeah. You mean land with one eye shut? No. Oh yeah, turned on the pilot controlled lights. Yeah. Yes, I have. It works pretty well, and it goes for about 15 minutes. So if I think I'm coming in and I'm about 12 minutes out when I do it, if I'm coming in to land on final, I'll probably do it 7 times, so the lights won't just suddenly disappear when I'm like 50 feet off the ground. All right. So there's 4 kinds of rotating beacons. We've looked at the symbol for a rotating beacon on a chart. Let's see if anybody can remember. If Jordan was here, I'd let him pick his name out of the cup, but Jordan's not here. I've been picking Jordan lately. What symbol on it that tells you there is a rotating beacon at that airport? Yeah, there's a star on the airport symbol. That's right. So now the question is when is the beacon on? Can you name one of those 2 times the beacon gets on? Would you see it very well in the day? Say no. So when do you think the beacon would be turned on, Mauricio? Try again. When do you think it would be turned on? You got a 50-50 chance here. Try again. Yeah, at night. All right, it works out much at night. And if I didn't say it clearly last time, it gets turned on at sundown and goes until sun up. Because remember that after the sun goes down, there's still 10, 20, 30 minutes that you can still see, right? It's the same as when do you have to turn on your navigation lights on the airplane is from sundown until sun up. Even if you don't get to count it as nighttime in your logbook, it still counts. So the next question is, if you'll remember, when is the other time that a beacon would be turned on at an airport? Yeah, that's right. Very good. It's at an airport where the weather is less than VFR. So if that thing's on during the drive out to the airport and the beacon's on during the day, you're probably going to also notice there's a whole bunch of low clouds or it's foggy, and you're probably not going to get a fly because if you're only flying VFR, because the weather is worse than VFR. So that beacon has different colors depending on what kind of airport you go to. Most of the airports in the United States are civilian airports. You can take off and land there all you want as a civilian, and it alternates white and green. I'm going to show you a movie clip here shortly. Military airports are white green. So like if you flew to Hanford Airport and Lemoore Naval Air Station Airport was 10 or 15 miles away and it was at night and you were at the right over there, you'd see a light and it'd go white, white, green, white, white, green, because Lemoore Naval Air Station is a military airport. 2 most likely colors you're going to see, Brian. Yeah, it does. Oh no, the light that's on the airplane. Collision lights on airplanes are white or they're red, and they blink on and off and on and off and on and off. Actually, I have seen a collision light where the glass on top of it, the front of it was white and the back of it was red. So, still, it's either white or red. So yeah. Besides, if you're looking out, it's not. I think I understand why you're asking the question. Are you going to confuse a beacon versus an airplane? And the answer is not very likely because the beacon's all the way on the ground. So seaplanes, if you're landing at an airport, for instance, Juneau, Alaska, or a better one is Anchorage, where they land jet airliner, have a lake they dug out runway, and they keep it full of water. They got plenty. Have a runway, but it's made out of water. Yeah, I know. I've never flown a seaplane one of these days. And heliports, Rodrigo, they flash green, yellow, and white lights. So they have 3 lights. So now we're going to watch this nice little video that shows lots of airport lights, not just rotating beacons.
Specialized lighting helps pilots find the airport and runways at night and assist with altitude control during landings. At towered airports, the lighting is usually controlled by the air traffic controllers. At non-towered airports, the lighting can be controlled by timers, photo sensors, or by the pilots over the common traffic advisory frequency. Pilot-controlled lighting is activated by keying your microphone for a certain number of clicks within 5 seconds. The number of clicks determines the intensity of the lighting. Most pilot-controlled lighting will turn off after 15 minutes. Information on airport lighting is found on aviation charts and in the airport facility directory. Lighted civilian land airports have a rotating or flashing beacon that flashes alternately white and green. This beacon is usually installed at the top of a metal tower, on a hangar roof, or, at most controlled airports, on the top of the control tower. These beacons flash 24 to 30 times per minute and are aimed at an angle of 1 to 10 degrees above the horizon, so they are best seen when you are at a distance from the airport and may be difficult to see if directly overhead. Rotated beacons are illuminated dusk to dawn, and at controlled airports are often turned on in the daytime whenever the weather is not sufficient for visual navigation. Military airports flash 2 whites between each green, while seaplane airports flash alternating yellow and white. Heliports flash green, yellow, white. Runways with an instrument.
So, Rodrigo, on the final exam, when you get your exam, I'm going to cross out airports and I'm going to write heliports. So you're going to have to know what lights are for a heliport, okay?
A landing system, or ILS, also have approach lighting systems, or ALSs. There are many different configurations of lights used depending on the environment, but they generally consist of long rows of steady lights with lateral bars, and sometimes include a central set of sequential flashing lights. This light system is designed to help a pilot rapidly transition from flying by their cockpit instruments to flying by outside visual references. The ALS helps the pilot identify the runway environment and orients him for the visual land.
Now that looks pretty bright here, doesn't it? Okay. What if it was foggy? Would you be able, with those lights looking bright? No. So the main purpose of these airport, these ALSs, the airport lighting systems, is not just for VFR aircraft, but these one lights out in front of the runway. Those are for the IFR aircraft, the aircraft that are flying in the clouds, and the pilot's looking out the window trying to find the runway. That's why these lights are so terribly bright. What you can do if you're flying into an airport that has a tower and you're flying VFR at night and they're too bright, you can ask, and the air traffic controller is happy to turn those lights down. They'll even turn them off if you want them to.
Another light system that can be used is runway end identifier lights, or rails. This system consists of a pair of synchronized flashing lights on each side of the end of the runway and allows airports to provide rapid positive identification of the approach end of that particular runway. Flashing lights on.
You also notice we're coming in to land on this airport. It's hard to see, but there's actually a row of green lights right here. So that marks the beginning of the airport, or the runway rather, and it's hard to see. You can only see 1 or 2, but there's actually red lights on the far side. And the way they do it is these lights here, the glass cover, on this side it's green glass, and on the exact opposite it's red glass. So an airplane coming into land in the other direction would see this end as green, and they would see their far end as red.
Each side of the end of the runway, and allows airports to provide rapid positive identification of the approach end of that particular runway. To assist pilots on their visual landing approach, especially at night or in poor visibility, VASI and Pappy lights can be installed alongside selected runways. These aids are usually set to show a 3-degree approach path, but at some airports with higher obstructions, the projected angle may be as steep as 5 degrees. VASI, or Visual Approach Slope Indicator lights, are installed alongside the runway, both slightly before and slightly past the desired touchdown point. When above the desired approach path, the pilot sees white lights, and when below it, they see red. By keeping the near lights white and the far lights red, they know they are on glide path.
So if you have this type of lights, this is VASI, V-A-S-I, it's on your notes. If you follow these lights exactly right and keep the top ones red and keep the bottom ones white, and you don't flare the airplane, all you do is just fly it right down and hit the runway, you'll end up hitting the runway exactly halfway between the white and the red lights. So if you're in the daytime, I'm going to back up here just a little tiny bit. If it's the daytime, so if they're both white, that means you're too high. If all the lights are red, that means you're too low. And hopefully that makes pretty good sense if you're used to driving automobiles in the United States. Red is a bad thing, at least if you're moving your car through an intersection. And although white doesn't really have much of a connotation, we don't have that many white lights driving cars. So if it's red, if they're all red, you're too low. If they're all white, you're too high. And if half of them are red and half of them are white, that's good. The next thing is we're going to talk Pappy, which is a similar system, but it also works out that way. If half of them are red and half of them are white, you're just right. If more of them are red, you're too low. If more of them are white, you're too high. In fact, you probably didn't notice, but in the simulator at Reedley Airport, there's actually, this is VASI, there's Pappy, and the video is going to cover Pappy here right away.
The pilot's Pappy, or Precision Approach Path Indicator lights, work similar to VASI's, but with 4 lights installed in a single row, with each light angled slightly higher than the previous. Here, the task for the pilot is to keep the outboard lights white and the lights closest to the runway red. 4 white lights would indicate that you are too high. 3 whites and 1 red indicate that you are only slightly high. 2 whites and 2 reds means that you are on the correct angle.
Okay, so that would be the perfect approach if you wanted a 3-degree approach. And just like the VASI, or similar to the VASI, if you kept half the lights red and half the lights white, and you fly the airplane and you don't flare it for landing, and all you do is just fly the airplane straight down, keeping both two lights white and 2 lights red, you're going to touch down on the runway right next to those lights. Now, let's see. Anybody want to tell me what these big white gizmos, what do we call them? We call them refrigerators. How far, other than Josh, who can tell me how far down the runway they are? 1,000 feet. So what if we have a 3,000 foot long runway and we touch down right here? How many feet do we have left? 2,000 feet. Okay, what if we're in a bigger airplane that needs a longer runway? What if we want to actually touch down here 800 feet before there? What are these lights going to look like if we're lower than those lights tell us to be? Yeah, more of them are going to be red. Maybe another one will be red. Maybe even all 4 of them will be red. So that's okay. You don't have, if there's a Pappy or a VASI, it doesn't mean you have to fly them. It just means if you do fly them, you're going to touch down where the lights are going to tell you to touch down. But that doesn't mean you can't fly a little bit lower. That's okay. And if you're in a bigger airplane and you need that extra 1,000 feet, you may need to have more of the lights red and touch down early. One of the things you're going to do in your pilot training is you're going to be asked on your private pilot check ride, you're going to be asked to land the airplane on the runway and simulating an engine failure. You're going to have to plan on where are you going to touch down. So you're going to want to be thinking about that. I personally don't like to aim for the refrigerators because that's 1,000 feet down there. So I usually have to try to land between the first set of white stripes and the second set. So this distance here is 500 feet. So say, you know what, I want to touch down at this first set right here, because now I usually have a whole lot more runway left.
2 whites and 2 reds means that you are on the correct angle. As you can now guess, 3 reds and 1 white mean that you are slightly low, and 4 reds mean that you are too low. Pappies are most commonly installed in larger airports with instrument approaches.
What you're going to find is both the VASI and the Pappy, both of these visual aids to landing, that glide slope on the final approach, they're wonderful at night. Because at night, you can't see the dirt and the grass and the poles and the fences. So it's a lot harder to tell just by looking out the window how far above the ground you are. But if they've installed a Pappy or a VASI and you keep half of them red and half of them white, you're guaranteed not to hit any trees or grass or fences.
Runway edge lighting consists of white lights mounted on short posts about...
Is there a question there, sir? Yes. Yeah, it doesn't actually say it on the chart. It has it in a booklet, and you look up that airport, and that tells you what frequency to talk on. It tells you how high the traffic pattern is, and it'll tell you whether you got a VASI or a Pappy, and it'll tell you which runway it's installed on. Because like Fresno Air Terminal, for instance, it has 2 runways. They may only put the VASI or the Pappy on one of them, but you might want to know, is it on both of them? Interestingly enough, the Reedley City has spent a lot of money on the Reedley, and it has Pappy, which is actually a little bit better than a VASI.
90 to 180 feet along the runway edge. A row of end lights can be installed with split lenses, green facing the approach end to mark the beginning of the runway, or if approached from the opposite end, would identify the end of the runway. Runway lights are classified as high, medium, or low intensity. Some airport runway light intensities are fixed, while at other airports the brightness can be changed by the controllers or pilots. On more sophisticated runways, yellow lights are used instead on the last 2,000 feet of the runway or half the runway length, whichever is less. This marks the caution zone for landings. Runway centerline lighting is flush mounted into the runway itself, with lights about every 50 feet. White lights begin at the approach end, transitioning to alternating red and white lights when at 3,000 feet from the end of the runway, and then becoming all red lights for the last 1,000 feet of the runway. Alternating green and yellow leadoff lights can be installed to direct pilots to the taxiway exits. Taxiway lights are used to outline the edges of taxiways and are blue in color. Some airports may also install taxiway centerline lights, which are green in color. Just like runway centerline lights, these lights are embedded into the ground.
All right, so we've effectively covered this. If somebody says ALS, they're talking about approach light systems. Who are approach light systems mainly designed for? Are they designed for VFR pilots? They're designed for IFR stuff, so you're going to write that down. It's not that you can't use them, but they're really bright, and they're really there for use in visibility when there's lots of clouds or fog. And of course, as a VFR private pilot, we're not going to fly in low visibility or in the clouds. Of course, we already covered, it showed that the runway edge lights are usually white. The only time you're ever going to see that last bit of the runway in yellow is if you're at a big giant airport like Los Angeles International. The runway end identifier lights, you know the abbreviation for that, REIL. Why don't you write REIL there on your notes? Runway end. Why it says rail, because rail is in the United States is spelled AIL. But remember, if the green lights are to you, that's where the runway begins. Now, think about that. Are you going to be able to see those arrows or those chevrons painted on the runway asphalt at night? No. So this is how you know where can my wheels hit the runway. So just hit right after the green runway and identifier light, identification lights. All right, and then of course the video said that the taxiway lights are blue. The good news is, I was watching this video literally just now, and I thought, holy mackerel, if I tried to make you tell me every single stupid little detail about lights, it would be rather confusing and overwhelming. It's not that bad. It's not that bad. The other nice thing you do is you get yourself an iPad and put a computer program, and the computer program I have, now granted it's $200 a year, but it gives me all my charts. If you're at Fresno and you call it up, it'll show you on the taxiway. Actually show you as you're taxiing on the airport diagram. So you can know if you're on taxiway Alpha Bravo Charlie or if you're going in the right direction. So it's really, really, really worth it in the long run if you're going to fly professionally is get an iPad and put ForeFlight or X-Wing or some other aviation program on it. All right, we've already covered VASI and Pappy. VASI is a four-letter identifier, a four-letter abbreviation for Visual Approach Slope Indicator, and Pappy is Precision Approach Path Indicator. And of course, you ought to be able to, who can't answer this question? Remain seated. Oh, none of you know the answer? So, Freddie Rick, do you know the answer to that question? If you're not too high and you're not too low, what are the lights going to be looking like? Two red, two white, or at least half of them will be red and half of them will be white. So whether there's one on top of each other or there's four going to the side, it's still the same answer. If half of them are red and half of them are white, then you're on the path that the lights are trying to have you on. So what's going to happen, Freddie Rick, if more than half of the lights are red? What does that mean? You're too low. Very good. And if more than half of the lights are white, that means you're a little high. Okay. So one last question for the VASI or the Pappy. Let's say it's in the daytime. Can you fly that approach and have most of the lights red? Is that okay? And if yes, tell me why. I got Freddie Rick. I can't. Shirley. Jonathan. It's day coming in to land at an airport. Is it okay if you're flying a VASI or a Pappy and most of the lights are red? Is that all right? Tell me and wonder what circumstances you do that. And? Right. You don't want to land 1,000 feet down the runway. You want to land at the very beginning. All right. That covers airports. So now we're going to start Chapter 4, Section C, charts. We've only got a little bit of time left for today, so I'm not going to pass out charts. Tomorrow, I know we've already looked at charts, but we're going to look at a few more things on charts. So the first thing I want to cover is latitude and longitude. If you're going to be a pilot, even a VFR private pilot, you need to understand. And if you take the true North Pole, remember that's not the magnetic North Pole, but if you take the true North Pole, so all these lines go up here, and they go to the true North Pole. And this line going all the way down to here, the true South Pole, these are all the same length. They're all long. So these are the longitude lines. So those are the longitude lines. Each line of longitude goes from the South Pole to the North Pole, or you could say it goes from the North Pole to the South Pole. And each one of these lines is 12,000 nautical miles long. Let's look at this one over here. Here's a line of longitude. And it goes here, and it's way over there in the Pacific Ocean, and it comes right there. Okay. This line is 12,000 nautical miles long. And there's 360 of these. If we look down on top of the Earth, there's 360 of these. All right. The lines, let's look at the equator. This one this is the most famous line of latitude. I remember latitude because all the lines of latitude are flat. That's the way I remember which ones are latitude. And they're all different lengths. They're not all long. So this line around the equator, this one latitude line around the equator, all the way around, half of it is 12,000 nautical miles and the other half is 12,000 nautical miles. But look, the closer I get, if here's the Earth, how about this line of latitude that goes all the way around the Earth? It's not 12,000 nautical miles. So the lines of latitude, they're all flat. You could also describe them as all the lines of latitude are parallel to each other. All the lines of latitude are parallel to each other. Anybody want me to spell parallel? There's 3 L's in parallel. They're all the same distance from each other. The lines of longitude, look at this line of longitude. If I come up here, this next line of longitude right here, up near the North Pole and down near the South Pole, these lines are not very far apart. Here at the equator, they're the farthest apart. So this is one way to identify where you are on this planet. And this becomes extra important in 2 places, which you're going to write down. Number 1, when you're looking at an aviation chart, an aeronautical chart, the lines of latitude and the lines of longitude are printed even on a VFR chart. They're printed on VFR charts. So you need to understand what they do and what they mean. And then the second really good reason why you need to know latitude and longitude is because that is the basis of GPS information. GPS data works off of latitude and longitude. Anyone here that has ever navigated in a vehicle or been in a vehicle where somebody was navigating with GPS? Almost half the class. So that GPS inside of somebody's phone, I don't think anybody buys handheld GPSs anymore. It's relating the latitude and longitude of where you are on the planet, and then it's putting that location onto a map. So it doesn't display latitude and longitude, it displays a map, but that's how it all works. You had a question, Jaron? Okay. So longitude lines go from the true North Pole to the true South Pole. They're all 12,000 nautical miles long, and they all are the same length. The lines of latitude, none of them are the same length. They're all different lengths, but they're all parallel to each other, and they're all the same distance away from each other. And the closer you get to the North Pole or the South Pole, a line of latitude is actually shorter. Did I lose anybody there? When we look at the charts tomorrow, we're going to look at latitude and longitude some more. Today, we're just covering basic maps. Now, there's 3 ways. Now, anybody ever peel an orange and got that orange peel in just one giant piece? You've never peeled an orange and had all the orange peel still stuck together? Oh, all right, well, it's my fault for not bringing oranges, because if I had those oranges, we'd all be peeling an orange right now. The problem is if you take a sphere, a ball, you try to flatten it out and have it look correctly, the ball splits and it tears while you're trying to flatten it out. So paper maps trying to display a curved sphere is you have to have something that's torn or stretched or inaccurate. There is literally no perfect way to take a round globe and the Earth and flatten it out on a piece of paper and have it be perfect. What aviation charts are going to do is have the least amount of issues that negatively impact your ability to navigate. This type of a projection, the Mercator projection, you'll notice that look at all the lines of longitude going straight up and down. In this projection here, all the lines of longitude are the same distance apart. So, but that doesn't work out very well for them all trying to get to the North Pole, right? The North Pole is not a line all the way across. The North Pole is a point, Brian. No, when we were out at the compass rose, we were either looking straight ahead and lined up with the true North Pole, or we had to turn 13 degrees towards the east, and that was the direction of the magnetic North Pole. In this chart right here, the magnetic North Pole is around here. So if we're here in California, that goes up to the true North Pole, and the magnetic North Pole here in California, that's about 13 degrees difference. Or it's 13 degrees to the east, or it's called 13 degrees east variation. But if I was over here in Maine, the true north is here and the magnetic north is there, I'd have to turn to the west. That would be called westerly magnetic variation. So in reality, these lines, this line is supposed to be curving up and touching this one, and this line is supposed to be curving up and touching. So what ends up happening is if you spread this out to keep all these lines of longitude. So here, I'm just going to use this line of longitude right here. So this is a line of longitude. In order to spread them out so that they're all parallel, things that are close to the North Pole and things that are close to the South Pole, whoops, giving away all my good slides there. Things at the North Pole and things near the South Pole are enlarged. They look too big. For instance, what I want you to notice right now is here is the island of Greenland. How big is the island of Greenland compared to the continent of Africa? Are they approximately the same area, the same size? On this map, on this chart, they look the same, right? All right. Okay. So on a Mercator projection, if you do it like this, things on the equator look relatively small, and the farther you go to the North Pole or the farther you go to the South Pole, they look too big. So on a Mercator projection, the longitude lines are parallel, and it distorts the area. Things look too big near the North Pole, and things look too big near the South Pole. The Peterson projection, it has a distorted shape. That is, the shapes aren't very accurate, but the area is accurate. Literally, look now at the site. Now, Greenland is distorted, okay? But that's how big Greenland is compared to Africa. Now, how big is Greenland compared to Africa? Greenland's a whole lot smaller. It's because here the area of these things, all these countries or all these continents or all these land masses are correct in the amount of area, but their shape is still distorted, in particular the farther you get away from the equator. This last one, Conformalconic Projection, this is the kind of way to project a chart, to draw a chart, to use for aviation. You'll notice the lines of longitude. So that line of longitude we were looking at, the one that goes through England. So here's England, and here's Scotland, and there's Ireland. This line that goes through England to the North Pole, you'll notice all these lines of longitude, they all come together. So yay, that's great. So the shapes are pretty good. So there's less distortion, and this is what's really important, and this is why we esse the Conformalconic projection in aviation, is because I can draw a straight line from Reedley, California, and I can draw it straight to Great Britain, to London, and that straight line is the shortest distance to get there, because that's what we want to really do as pilots. When we take off and fly somewhere, we want to burn the least amount of fuel. We want to get there as fast as we can. So we need a chart where straight lines are really the shortest distances. Now, if I pumped this up, if I went behind this screen and pushed it out, this Earth would be curved out. If I actually looked on that curve from Reedley to Great Britain, it's actually curved across the Earth. It'd look flat. It'd look like a straight line for you all. But what if I turned the Earth sideways? It would look like a curved line. But it's still the shortest distance on a sphere, the shortest distance on the Earth. So I think that's enough for charts for today. It's, we'll say it's 12 after in real life, so 27 after on your clocks in the computer lab, 27.